Hi, I am Mohanraj from Puducherry. So today we are going to discuss about trigonometry. As the name itself, we can understand that tri, it means three sides. So we are going to deal this topic with a three-sided figure. Yeah, you are right. That is triangle. But what type of triangle it is? Yeah, very good. It is right angle triangle. Okay, let me name the angle C as theta. So, whenever I compare this theta angle C, I can get the other sides. So, the side opposite to theta is called as opposite side. The side adjacent to theta is called as adjacent side. Adjacent side, and the longest side, which we call it as hypotenuse. Hypotenuse. Okay. With this right angle triangle, a mathematician Pythagoras derived one theorem, and it is hypotenuse square is equal to sum of squares of other two sides. It means hypotenuse square AC square is equal to AB square plus BC square. Is it clear? So this property is applicable only for right angle triangle. Then when we discuss about trigonometry, we can have six different ratios like sine, cos, tan theta, cosecant theta, secant theta, and cot theta. Okay. Each of these ratios have different values depending upon their angles. So let us consider a triangle, a right-sided figure called as a right angle triangle. Okay, we can split these ratios as 0 degree, 30 degree, 45 degree, 60 degree, and finally 90 degree. So I am using this 30, 45, this one is 60, and finally we are getting 90 degree. So initially I am marking the 0, 30, 45, 60 and 90. Now how to find the values of these sine, cos, tan, cosecant, secant and cot? There is an easy method. So we can split this into 4 fractions. So first one is 0, second one is 1 by 2, third one is 2 by 4, which can be split into 1 by 2, sorry, 1 by 2, 1 by 4, sorry, 1 by 4, 2 by 4 can be written as 1 by 2, 3 by 4, this one is 3 by 4, and finally 4 by 4, which can be written as 1. So now we can take square root. So square root of 0 is 0. Yeah, that is the value of sine 0 is 0. And then sine 30 degree. The value of sine 30 degree is, what is the square root of 1 by 4? 1 by 2. Square root of 1 by 2 is 1 by root 2. That is the value of sine 45. And what is the value of sine 60 is square root of 3 by 4, which is root 3 by 2. Square root of 1 is 1, means sine 90 degree is 1. Now I am inversing the value. So from 90 degree to 0, I am writing it in descending order. 1 root 3 by 2, 1 by root 2, 1 by 2 and finally 0. This is the value of cos theta. Next, tan theta. When we divide sine by cos, we get tan ratio. So 0 divided by 1 is 0. 1 by 2 divided by 3, root 3 by 2 is 1 by root 3. 1 by root 2 divided by 1 by root 2 is 1. Root 3 by 2 divided by 1 by 2 is root 3. 1 divided by 0 is not defined. So because 0, we can't divide any number with 0, that is not defined. So cosecant is similar to sine, but the reciprocal of sine is cosecant. So 0 can be written as 1 by 0, which is not defined. This one is 2, root 2, 2 by root 3, and this is 1. Once again I will be inverting cos. Inversion of cos is secant. So 2 by root 3, root 2, 2, and this is 0 by 1, not 1 by 0, which is again not defined. So cot is inverse of tan 0. Tan 0 is 0 and cot 0 is 1 by 0, which is not defined. And then root 1 by root 3 can be written as root 3 1, 1 by root 3 0. Is it clear? So this is how we fill the ratios of sine, cos, tan, cosecant, secant and cot. We don't need to memorize these values, but the frequent values can be remembered. Next, we are going to see about some identities of these ratios. So, first identity, sin square theta plus cos square theta is equal to 1. From this identity, we can derive two sub-identities. So, sin square theta is equal to 1 minus cos square theta, or cos square theta is equal to 1 minus sin square theta. Next, 1 plus tan square theta equal to secant square theta. Again 2 can be derived. 1 is equal to secant square theta minus tan square theta. Tan square theta is equal to secant square theta minus 1. And last identity, which is 1 plus cot square theta is equal to cosecant square theta. Again 2 can be, 1 is equal to cosecant square theta minus cot square theta. Cot square theta is equal to cosecant square theta minus 1. So we have discussed about the basic formulas, identities and ratios in trigonometry. Now, so we have discussed about Pythagoras theorem and ratios, how to fill these tabular columns in these ratios and identities. There is an easy way to remember this identity with the help of an hexagon. Let me draw the hexagon first. Hexagon is a 6-sided figure. Okay, so first I am writing sin theta, cos theta, opposite of sin is cosecant theta, opposite of cos is secant theta, and remaining is tan theta, opposite of tan is cot theta. So I am writing value as 1 here. Okay, now I am squaring this: sin square, cos square, cot square, cosecant square, secant square, tan square. We can start with sin square theta. So move in clockwise direction. Sin square theta plus cot square theta, which results 1, our first identity, and then leave one triangle and move on to the second triangle. Now 1 plus cot square theta is equal to cosecant square theta, our third identity. 1 plus cot square theta equal to cosecant square theta. And last, So leave one and move on to the next. Tan square theta plus 1 is equal to secant square theta. That is our second identity. 1 plus tan square theta equal to secant square theta. We no need to memorize any formulas. Just you can understand the concept, and whatever may be difficult the problem is, you can solve in an easy manner. So that is what. When you are clear with the concepts, you can solve any kind of problems. Okay, let us discuss with a problem now. Okay, first we can solve this. This is from your chapter 8th chapter from class 10, 8.3 exercise. In that fourth sum, eighth subdivision, fourth sum, we are going to solve eighth subdivision. Okay, so in this what they are asked is to prove sin a plus cosecant a whole square plus cos a plus secant a whole square is equal to 7 plus tan square a plus cot square a. Either you can solve in two methods. Either you can go with LHS, that is left hand side to right hand side, or from right hand side to left hand side. Usually in most of the sum we will solve from left hand side. So first of all we can write LHS. What is LHS? Sin a plus cosecant a whole square plus cos a plus secant a whole square. Okay. After observing this, you can get an idea of it is in a plus b whole square form. So what is the formula of a plus b whole square? A square plus b square plus 2 into ab. Yes, exactly. These formulas we are going to use now. So what will happen? We substitute sin a in place of a and sin cosecant a in place of b. So sin square a plus cosecant square a plus 2 sin a cosecant a. Okay, and then second term is also in the form of a plus b whole square. So again I am writing as cos square a plus secant square a plus 2 cos a secant a. Okay, we know an identity like sin square a plus cos square a equal to 1. Is there any formula like that? Yeah, sin square a cos square a. I am rearranging it. Okay, I am rearranging it as sin square a plus cos square a. Okay, second one is, so I can write cosecant a as reciprocal of sin a. So 2 sin a into 1 by sin a plus, and then secant a can be replaced as inverse of cos a, that is 2 cos a into 1 by cos a plus, is there any identity related to cosecant square a and secant square a? Exactly, we have separate identities. So cosecant square a is, I can write cosecant square a. Cosecant square a is equal to 1 plus tan square a, and secant square a, sorry, formula is wrong. Cosecant square a is equal to 1 plus cot square a. Secant square a is equal to 1 plus tan square a. Yeah, I am replacing cosecant a with 1 plus cot square a. 1 plus cot square a, and I am replacing secant square a with 1 plus tan square a. Okay, is there anything to be cancelled? Yes, sin a and sin a can get cancelled, cos a get cancelled, and sin square a plus cos square a is 1. So 1 plus 2 plus 2 Already we have 1 and 1 here, so I am combining it as 2 plus cot square A plus tan square A. 6 and total is 7 plus cot square A plus tan square A. I am rearranging as it is given in the question. 7 plus tan square A plus cot square A equal to RHS. That's all. We have proved. Is it clear? So we can go with the next problem, which is 10th sum, 10th subdivision, the same sum. So in this, they have given three equivalent values. 1 plus tan square A by 1 plus cot square A is equal to 1 minus tan A by 1 minus cot A whole square is equal to tan square A. First, I am comparing these two. I am going to prove 1 plus tan square A by 1 plus cot square A is equal to tan square A, and then this one. 1 minus tan A by 1 minus cot A the whole square is equal to tan square A. First of all, I am going to write with 1 plus tan square A by 1 plus cot square A. 1 plus tan square A. I am transforming everything in terms of tan because in right hand side the answer is in tan. So I am writing cot as 1 by cot A, sorry, 1 by tan A. Cot can be written as, cot theta can be written as 1 by tan theta. So 1 plus 1 by tan square A. Now I am taking LCM for denominator. 1 plus tan square A, again 1 plus tan square A whole divided by tan square A. I am reciprocating the denominator. 1 plus tan square A into tan square A divided by 1 plus tan square A. These two will get cancelled and final result will be tan square A, which is our proof. Now I am solving the second part of this. 1 minus tan A divided by 1 minus cot A whole square. So again cot A can be written as 1 by tan A. So 1 minus tan A divided by 1 minus 1 by tan A whole square equal to 1 minus tan A divided by tan A minus 1 divided by tan A whole square. So now I can't cancel this because here 1 minus tan A and here tan A minus 1. So I am taking minus common. 1 minus tan A divided by minus of 1 minus tan A into tan A, reciprocating it whole square. So minus into 1, minus 1, the previous answer, and minus into minus plus. So that's how. Now these two can get cancelled. So remaining will be minus tan A whole square minus tan A whole square can be written as tan square A, hence our result. In this way we can solve very easily. So just be clear with the concepts. Any problem can be solved without fear. So thank you for watching. Thank you.